Hello, boys and girls. Alright, so in my last video I said we only covered the first two. I was wrong. We actually did cover all three of these. Students will know the four types of exponential functions and what their graphs look like. Bam! Now the most important thing is, why do we use them, where do they come from, and why are they important, and state the domain, range, y-intercept, x-intercepts, and behavior of an exponential function. Alright, so exponential function. Why is it important? Alright, so here's a famous game I play in class. The $1 million mission answer key. You're sitting in math class, mind your own business, when in walks Bill Gates kind of guy, rich guy. He has a job offer basically, and he says, alright, you've got two choices. When you get on your, if you your salary, number one, you can either get paid 1 cent on the first day, 2 cents on the second day, and double your salary every day thereafter for the 30 days, or you can get paid $1 million. What is your choice? Yeah, and so some kids will automatically say, oh, I'll take the $1 million because it's a lot of money, and other kids will be like, I think this is a trick question. It is a trick question. And here's the beginning worked out, right? The first day you get 1 cent. The second day you get another cent. It doubles. See how they're doubling over here? But over here, this is the total. So by the 7th day, you're getting $1.27. Well, that's ridiculous. But then by the 14th day, you're making a total of $163. So in 14 days, you've made only $160. Crazy. But then by day 21, remember you only got a month. Holy cow, it's gone up to $20,000 because it's doubling 163. This is per day now, 327. Now it goes to 5,000 and then to 10,000. And there you go, by day 30, you've made $10,737,000 versus $1 million. This is an exponential function. Alright, to graph what was going on here, I had to tweak the function a little bit because at day 0, we wouldn't actually be making 0.005 cents, but at day 1, we'd be making 0.01 cent, at day 2, 0.02 cents, 0.04 cents, 8 cents, 16 cents, and 32 cents. So what our function, so this is what our graph would look like, but our function, we'd have to start at a equals 0.005, and our b value would have to be at 2. So that's going to give us the functions that we want. And then we'd kind of set our domain, honestly, that the domain would have to be start at 1 and only include day 1 and 2. You wouldn't even have the in-betweens, right? You'd have day 1, day 2. Anyway, the important thing is that the b value is our growth factor. It's going up by, it's doubling. That's our b value. So when we use this one over here, our b value, this number here to the x power, is going to be the growth factor. That's our growth factor. So here's one example of what it's used for. So let's say, so this is the daily trends in November of COVID-19 cases in the United States reported. So this is January of last year, right? And what happened was right here, this is why we shut down. So if I zoom in, so basically if I take a screenshot of just that one little area there, I'm going to put it on Desmos, and we're going to graph it and we're going to see what it looks like. Okay, so I put this on here. I'm going to center it and I'm going to get it all ready. Okay, so it took me a little while, but I scaled the picture so that that matches to the Desmos graph. And so basically this is why we shut down. This is what we saw by February, March, right? Exponential function where at the very beginning it's 0, 0, 0. You'd have a couple cases, right? This is at 10,000, by the way, so if we were to zoom in, and you know, it's super thick, so you can't really tell what's going on, but this is what started to happen, right? And so we're looking at right here, this was at like 30,000 cases. We went from 0 to 30,000 in a couple months. So we shut down. What ended up happening because of the shutdown, right? Started to level out, everything looked good. Then the summer hit. Then it skyrocketed again. We shut down again. And then Christmas hit. Right here. Let's see, like, this is Christmas. December 29th. Right? Thanksgiving. There's our holidays. Shot up, and then right after January 1st, right? And then we started getting serious again. And then this is us now, down here. But it was an exponential function. It was increasing. I'll show you a sec, the numbers. This is a website called Worldometers, and basically they give you data on everything. This one particularly is for COVID. So notice the words growth factor. So they were using the growth factor. The important key was growth factor is the factor by which a quantity multiplies itself over time. The formula used is in everyday's new cases on the previous day. For example, a quantity growing of 7% every period, in this case daily, has a growth factor of 1.07. So if it was growing by a factor of 1, that just means it's staying the same. So 1.07, it's increasing 7% every day. So we didn't want it to increase. We want it to be a growth factor of above 1 indicates an increase, whereas 1 which remains between 0 and 1 is a sign of decline. So that's our decay factor. We want it to go down, and in that case, instead of having it grow, we want it to decay. We want it to go down. And then when we look at domain and range, what we're looking at, if we're looking at domain, we're saying, oh, you know what, I want to look at the time between January 24th, the domain would be to March 24th. That would be the domain. If I was looking at the range, I want to see how high it got. It got to be 7, whatever those are, daily cases growth, and I don't know what the scale is. 7 what? There we go. 6. Oh, the growth factor is 6.92. Right, but we would look at actual numbers. In this case here, our domain would be from probably January 22nd to April 16th or April 20th, 26th, whatever today's date is. Right, in this case the 25th, it looks like it's coming up on that. And the range would be, of course, from 0, because you can't have negative values, between 0 and whatever the highest peak here was at, what, 843, there it is. Wow. And we're still at our highest peak right now. Countrywide, by the way, actually I think this is in the world, and India's getting hit hard right now. So that's how domain and range fits into it. But we're not going to get into actual cases and stuff like that. That's just so you can understand what's going on. Okay, so let's get to it. Alright, so for the most part, you can just use Desmos. Copy the graph over to here. So it's going to kind of look like this. What's happening over here is that basically you're getting 1/2 to the 0 power equals 1, 1/2 to the 1 power equals 1/2, 1/2 to the second power is 1/4, right? If you remember that. But anyway, so these are basically, as x is getting bigger, it's getting closer and closer to the line right there. Right, so in this case, the domain, well, over on this side, it's going to keep going that way. It's going to keep going that way. So the domain is everything over there to the left. The range, so the domain on this side, it's going to go that way forever. So in this case, our domain is -infinity to +infinity. The range, well, the range is going up forever, but it's not going down forever. It's stopping right here at 0, right here at 0. So the range is anywhere between, and you always want to start with a smaller number, 0, and it's going to go up forever. It's going to not include 0. It's never going to touch 0, so it's going to be a soft bracket. And of course, infinity is a soft bracket. End behavior. So as x is getting smaller and smaller and smaller, y is getting bigger and bigger and bigger. As x is getting smaller, y is going towards infinity. As x is going towards infinity, y is getting closer and closer to 0. So this is a little bit different. Y-intercept is right here at 0, 1. And the asymptote, you are not going to be asked that on the test. Okay, and that's basically how you do it. It just keeps going more. So you can just use Desmos. The biggest thing is you might get a question that looks kind of like this. And so what's happening is this works as that up and down thing. So it's very much like before we had the h and the k. So think of it as this would be the transformation. Your a and b is the same, but then you have x minus h. And usually it's x minus 0. Your h is usually 0. And your k is going to bring you up and down. So k is the vertical shift, just like before. And h is the horizontal shift, just like before. So make sure you copy these notes down. You're going to need it. You are going to see something like this on the test. So what's happening? Well, your h here is 4. Remember, it's x minus h, so it's the opposite of it. And your k is negative 2. So basically, you're shifting 2 units down, and you're shifting 4 units to the right. So it's going to basically be your parent function of y equals b to the x power, or y equals I don't know, I'll figure that out. So plus shifts minus shifts. If a is negative, the function is, alright, sorry, let's go back to this. Plus, so if you have a positive, or if it says like this, minus, the minus is going to be this one, and it's going to shift to the right. If it's a plus one, it's going to shift to the left. If you have the vertical and it's a positive k, it's going to go up. If you have a negative k, it's going to go down. If a is negative, so if this one is here, there's a negative, it's going to move the function and it's going to turn it upside down. It's going to be a reflection, just like the quadratic was, across the x-axis. You copying this down? If the absolute value of a is greater than 1, so basically it's just saying if you have like a whole number, it represents a vertical stretch. So they're saying if it's like -3, -5, if they're saying that it's a fraction, so if it's 1/2, even if it's -1/2, if it's a fraction, it represents a vertical compression or shrink. That's what we used before, was shrink. Right? So over here, it's going to go up 5 units. And you've got 3 to the x power. So it's not going to shift left or right, but it is, that's your a value. It's going to be a stretch. Okay. And basically that's about it. And then we'll just practice some. You know what, let's have you practice this one here. So with those, let's do an easier one. With those notes, make sure you go back and you do those notes. So let's do this here. What is going to be the, how's it going to look? Is it going to be a shrink, a stretch? Is it going to be a shift, vertical, by how much, or horizontal? Okay, and that's it for the practice. Let's do one. Yeah, we did the domain and range already. And then basically we just practice a bunch, and basically that's your test. You will have to know whether or not it is an exponential growth or an exponential decay. Of course, growth, because it's growing, and decay, because it's shrinking. It's never going to go down to 0 unless, of course, it's shifted. Okay?